Good afternoon, everyone. We will start our session soon. We are waiting for the participants to join.
Divya, I think we can start.
Yes, sir. So, good afternoon, everyone. Without any further delay, we now proceed to the final lecture session on QC tools, recent advances, and future trends in food analysis by Dr. Vivek Kamambati, sir. And the session is yours, sir. You can proceed, Bashar.
Okay, okay, Divya. I'm projecting the screen. Is the screen visible?
Yes, sir, it is visible.
Okay, thank you. So now we are going to learn about quality control tools. What are the different types of quality control tools, and what are the recent advances and future trends in the food analysis? Just an overview, right? We will also try to solve some of the practical problems that arises in the quality department using various quality control tools. Right. This is the learning objective for this particular lecture. Uh, you know, After finishing the course, you will be this particular session. You will be able to understand the principles of quality control, and you will know what are the different types of quality control tools are available and where to use those particular tools. Okay, and you will also learn about how to examine the modern analytical advancements and automations, and you will also able to identify the upcoming trends and technologies, especially for the food industries. Okay, so what do you mean by quality control? Quality, quality is a very broad term, right? So it has nutritional aspect, it has sensory aspects, it has various the uh, why the product sells in the market, because of what traits. Okay, because of the quality. Quality means it's a degree of excellence in achieving something. Excellent product, good quality product. When do we say it's a good quality? If it meets all the specifications, right, given to that particular category. For what? For giving a very good take an example. Let us take an example. If I'm manufacturing biscuit, okay, if I'm manufacturing any kind of biscuits, with what I will compare? With a standard product, with already existing product in the market which is doing very well, right? Whether I will compare my product with Parley, or I will compare my product with Britannia or ITC, whatever. What does that mean? It means I am going to compare that with a benchmark standards, right? Benchmark products. For what reason we need to compare? To ensure the accuracy, reliability, and consistency of that particular product or analytical results that you are getting, right? Say suppose, for example, Britannia milk cookies. You have different types of nutrients enlisted on the packaging material, right? Carbohydrate, protein, fat, and different composition of additives are also being added. So what I will do, I am manufacturing biscuit which is almost equal to my composition is almost equal to the this particular Britannia milk bouquets. Then I have to compare the nutritional profile also, right? Nutritional profile, sensory profile, what is the texture. So this particular Britannia biscuit is the benchmark standard reference sample for my product, right? Then integral, it's a quality control. Quality control is nothing but it's an integral part of the quality assurance system. If you see, quality assurance is very broader picture. Under that, you have quality control. We'll discuss those things. And this particular quality control prevents non-conformities and supports the regulatory compliance. So what do you mean by this? Suppose some regulatory agencies, they give some protocols, guidelines, right? These companies are having quality control department, whether they are following the norms or the standards given by the regulatory agencies or not. So how do you do that? It's a quality department altogether. It is a continuous improvement process, right? If you take any industry, say suppose for example, even Britannia, they work in this way. Okay, so plan, do, check, act, PDCA. Any quality control department, they act, they work in this way. They plan for some, analysis, or maybe some kind of checkpoints they will take. They will do the analysis. They will check whether these things are okay or not. Then if it is not okay, what to do? They will act, right? PDCA is very important for any kind of quality control. What is the role of quality control in the food industry? Basically, it monitors the raw materials. If the quality of the raw material is good, then only the final product quality will be good, right? So it ensures the customer loyalty. And as I already told you, it ensures the repeat business and customer referrals. Okay, word of mouth, customer reference will be there. Okay, use this brand. This brand is good. Maybe this is affordable, or it has a very good quality, right? Monitors raw material quality, process parameters also, and finished product. What do you mean by process parameters? Here you have all the processing flow chart, all the processing steps involved in the industry, right? Say suppose for example, if you are you know dealing with any kind of bread manufacturing, or maybe cake manufacturing. Let's take a small example. Cake manufacturing. You have a reception where you stock all the raw materials required for the product. Then what you will do, you will take out how much quantity of raw materials are required, because different raw materials will be stored here, right? You will take the raw materials and then you will go with the mixing section, right? Initial mixing section will be there. There all the materials will be mixed, and then the dough will be prepared. What are the additives you are going to add everything in the mixing section. This particular department, mixing department, is different. And then the raw material storage department is different. After this, it will go to the baking area, right? In the baking area, you have a very huge tunnel oven will be there. Okay, so the product, whatever the mixing area, the product, that raw material you are getting here, you will be sending to mixing area. Then it will be shaped like a cakes here, right? Is a 1 kg cake, or maybe 2 kg. From that you will get a 100 grams cake. Whatever the cakes available in the market, it will be taken out from here. From one cake, 10 slices will be made. That one slice is packed separately, and then it will go to the grocery stores, right? And then it will enter into the oven. Here the temperature parameter is very much important. Temperature, and then the baking time. What is the duration of the product, right? Just after entering into the oven till it reaches the final part of the oven, right? What is the time required to bake the product? That is important. Okay, so what I'm trying to say here, in each and every section, right, after this you have a cooling section, right? After baking, you will send it to the cooling section. Then after that, you will send it to the packaging section. Each and every section has a different rule. Everything combined together is called as process, right? What are the parameters you need to check here? Here in the raw material reception area, the quality of the raw materials are very much important, right? You will have some specifications here. And then in the mixing area, the flow of ingredient mixture, right? The recipe is very much important. First, you will add, egg, then you will, blend it properly. Aeration will happen, and then you will put oil, and then you will put sugar. Like that, there is a sequential steps are there in the mixing area. After that, in the oven, you have processing parameters like temperature, relative humidity, and then what is the time, baking time. Here also you have certain cooling properties or parameters, right? This process parameter has to be properly monitored. Who will do that monitoring aspect? Quality control department will take care of each and every section, right? Till it reaches the packaging. Even after packaging, it reaches to the consumer. Even then, some of the complaints will be taken care by the QC department. Normally, this is what happens in big industries like Britannia or Parley or any big industries. Okay, then it ensures the quality control department ensures adherence to specification and safety standards. Right? Definitely, all the specifications are met or not. So, in the different sections, specifications are met or not. Then the safety standards. Right. So what are the safety standards? Example for oven for the baking process, you need to apply in the conveyor belt some grease has to be applied. You have to make sure that grease should not come into the cakes. Right. So similarly, there are different points where the safety standards has to be maintained. That part has to be taken care by the quality control department. Builds consumer confidence and brand reputation. Right. This is how the quality control department works. What is the difference between QA, quality assurance, and quality control, and how it is different from the, how it is related with food analysis? The main focus of quality assurance is the process oriented, right? Whereas in the case of quality control is the product oriented. So it is more of product oriented. Whether the product quality is good or not, whether contamination is happening or not, right? Whereas in the quality assurance, that's why I told you quality assurance is broader aspect. Under the quality assurance, you have a small component quality control, right? You are controlling, but here you are assuring the quality by using the process oriented. How process oriented is possible? By following the Kaizen approach or by following any of the quality control improvement tools, Six Sigma principles, for example, or any of the tools, right? There is one more term called Pokayoki, right? So many different words are there for controlling the quality to maintaining the quality, so that you can assure that your entire system is well maintained. Okay. And when it comes to food analysis, it's a data generation in both the departments, in the quality assurance as well as quality control department, because you have to do some kind of testing, right? For example, in the cake, you need to check whether the moisture content is fine, or whether the sugar is fine, or whether the baking color is okay, or this specification has to be properly checked, right? That's how the food analysis will be combined together with quality assurance and quality control. You cannot separate both the things. Okay, what is the approach? If you see, quality assurance, QA is the preventive approach. Okay, what do you mean by preventive approach? Prevention is better than cure, right? Before getting into trouble, you are making sure that each and every aspect is okay with respect to the process or product, right? Whereas in the case of quality control, you have the corrective actions. This can go wrong. Okay, you can check this one. Okay, this has gone wrong. So you correct those actions. Okay, in the future, the same thing will not be happening again. Here in the case of food analysis will be completely analytical in nature. It involves a lot of test procedures, testing and all. So that is the basic about quality control, quality assurance, right? So the next aspect is quality control tools. How these quality control tools are very much important. These are some of the tools and technique which can control the quality of the product. Okay, there are 7 basic quality control tools are available. The first one is check sheet, histogram, Pareto chart or Pareto analysis, cause and effect or fishbone diagram, control chart, and scatter diagram, finally flow chart. These are the tools which will help us, okay, in determining what is the problem in the process or the product. Okay, we'll discuss one by one. The charts will look like this. Cause and effect diagram, it looks like a fishbone. That's why it is called as the fishbone diagram. The check sheets already I showed in my previous lectures. What is check sheets and what are the importance of the check sheets, right? The Pareto chart will look like this, 80-20 principle, right? We'll discuss these things. Histogram, it looks like this. Control chart, you have upper control limit and lower control limit, under which your process parameters will be flowing. Okay. Scatter diagram, you have a scatter diagram. Using this, different points, you will find out what trend your sample, your process is having. Then flow chart is normal flow chart that all of us know the importance of the flow chart, right? The first one is check sheets. Where you can use these check sheets, it is used for systematic data recording. Okay, when the process requires systematic, data recording, then you need to use this check sheets. Identifies frequency of events or defects, right? Frequency means what? How many times the defects may occur in a week or in a month, right? Simple, it's a simple tool. Check sheet is very simple but effective for daily quality control operations. Okay, day-to-day quality operations. You see any industry in the quality control department, these check sheets are regularly being followed. Example, you can see frequency of spoilage incident per batch of any food production. We'll discuss, we'll learn by using some examples, right? Here, this is the check sheet for frequency of food spoilage incident per batch. What is the purpose? Purpose is to record and monitor the number and types of spoilage incidents occurring in different food batches. Okay, in the different food batches during the storage or distribution. This is very much important, right? So this is the check sheet available with you. The quality control manager will give you this check sheet if you are a quality control officer or executive. So the dates will be given like this. Okay, on 12th you are taking two different batches, 13, 14 and 15, right? Two batches on the single day, B101 and B102 is the batch. In the first batch you can see what type of spoilage is happening. Okay, what type of spoilage? Here you can observe mold growth is the visible spoilage. So what type of, take an example of bread here. Okay, any kind of food. But if you take a bread, then you can easily correlate, right? See here, in the first batch, mold appearance are there. Okay. See how you identify this particular mold growth? Fungal spots on the surface are visible. How many number of packets affected? 3 number of packet affected. Who is the in charge? Who is the quality control executive on that particular day or this particular batch? This is the batch 1. This is the batch 2. For the batch 1. Okay, batch 1 means shift 1 or shift 2, whatever you call. Okay, in the same shift, 2 batches are being produced. In the first batch, 3 number of packets are affected. Okay, especially in the storage or distribution department, this a particular person is responsible. He identified that there are fungal spots. Okay, similarly, the same person identified there is an order development in the batch 2. Okay, some kind of smell he can observe. Similarly, on next day, in one batch, color change was there. This was identified, brown coloration was identified by this particular person. Similarly, every day, what are the possible spoilage, types of spoilages are possible. Okay, if you maintain this checklist, then it is very easy. With respect to date, okay, what type of spoilages are occurring again and again? Okay, on 12th and 15th, you can observe mold growth, identified by 2 different persons. Okay, then there is a serious issue with the storage conditions, right? Because the mold is growing, right? Fungal spots on the surface, visible mycelium. Here, the number of packets affected 3 plus 2. Total 5 packets are affected within a week, right? Then this is a very serious issue. So how do you interpret this one? How do you interpret this one? You will see this is the type of spoilage, right? Mold growth, odor development, color change, gas formation. These are the frequently occurring spoilages in the industry. Any kind of food industry you can take, right? So in a week, let us take in a week, how many times this mold growth happened? Go to this particular check sheet. From the check sheet, you can tell mold growth 1, 2. So how you will write? You have to make 2 marks like this, right? First time, second time. Why? Because I will tell you, in this way, reading the tables are very easy, right? Instead of writing 2, 3, okay, how many times you are seeing? This is very small per week. If you take in a month, right? The check sheet will be very big. Every day, multiple batches will run. Okay, multiple times storage has to happen, right? And multiple shifts will be there. So it's a very complicated process, right? This check sheet will be very big in that case. If you want to compile the data for a month, then you need to take out so many check sheets, right? Maybe around 180 check sheets or 120 check sheets to identify the type of spoilage, common spoilage. Immediately, you have to check, okay, these are the 1 to 4 types of spoilages are happening in a particular month. Okay. So you will tick like this, 1, 2 times it happened this week. If in a month it happens 5 times, what you will do, the 4 lines you will give like this, and then the 5th line you need to enter in the slash like this or like this. Okay, cross line you need to mention. Suppose for example 1, 2, 3, 4 times it has already happened. Every fifth line should be represented with a slanting line. After that, again you can draw like this. 1, 2, 3, 4, like this. Okay. So first 4 line are straight lines. The 5th one will be slanting line in the check sheet. This is the standard, being used for the check sheets, right? So in a month, you can easily count anybody, if you can affix this check sheet on the notice board, immediately you can identify, okay, how many, 1, 2, 3, like that you can easily find out. Okay, 5th time, the slanting line means before that 4 times already happened. If you find, 5 number of slanting lines, then easily you can tell, okay, so 25 times this spoilage has happened. Okay, in that way, easily you can identify. That is called as the tally marks. Here in the previous example, mold growth occur 2 times, right? 1, 2. Color change 1 time, odor development 1 time, gas formation 1 time, right? The same thing you will observe. You will not give in this way. You will be giving the data in this way to the quality manager. Okay, interpretation. So what is the interpretation? Mold growth, 5 incidents happened. So if you go back, how many incidents happened? Frequent 1, 2, right? 3 plus 2 is equal to 5. 5 incidents happened for the mold growth is the most frequent spoilage type this particular week. Okay. Are you able to follow my lecture? Yes. Is it fine? I just want to hear from the participants.
Yes, sir.
Is it clear? Okay. If you have doubts, you please ask me. Okay. So this is how you need to interpret. 5 times the incident happened. Mold growth is the most common spoilage type for this particular food product storage, right? That indicates a possible issue with hygiene or moisture control. See how you are correlating. If mold growth is there, then one step you think ahead. Okay, what may go wrong? Okay, mold growth is there. What may go wrong? Maybe there is a, some hygiene issues or moisture control. Some water is, being it is not being properly dried, or there is some hygiene issues or some kind of issue, you can draw the conclusion like this. Further, what you can do to identify, see here, you are not identifying a root cause by using the check sheet. You are identifying what may go wrong. Hygiene is a very broad term, right? Where the hygiene, it includes so many things. For example, for workers, hand wash, that may be hygiene. Cleaning the floor, that may be hygiene. Again, you need to go one step further. What hygiene, right? Until you find the actual solution. This is how people do in the industry, right? Further, root cause analysis can be done, okay, by using this particular check sheet. You can uh, you know uh, you can identify the root cause, what may go wrong, what is the root cause of this particular hygiene problem, or what is the root cause of the more moisture content. Okay, more moisture content in the product. Because of the more moisture content, mold is growing. So something is wrong with oven, okay, or something is wrong with the equipment. We need to fix that equipment. That is how you derive the root cause here. Okay, the check sheets can later be converted into Pareto charter, prioritizing the problems. Okay, so how it is possible? Pareto tells 80-20 principle. Means 80-20 principle means what? 80% of the problem caused by 20% of the people or machine or parameters, right? So in this way, we can correlate this particular, this is very simple example I am discussing here, since our audience are mixed, right? We have BTech students, we have industry experts, and then we have PG students also. In order to make it very simply understandable, I have taken this very small example. But in industry, if you see, these check sheets are very big, right? It comprises of several pages. This is a small task, okay, for you people. Uh, if anybody can volunteer, you can do this one, right? This is second example for the check sheet. Recording foreign matter incident in packaged biscuit production line. This is the check sheet. This is check sheet. See here, I have increased number of days here. On the 21, three different shifts, two different shifts, 22 two shifts, 23 two shifts, 24 25 single shift, right? This is the corresponding batch number I have given. Types of foreign matter possible. What are the possible foreign matter will come in the biscuit production line? Okay, you have to list it down. Before this, you have to do the brainstorming. You need to list down what are the different types of foreign matter contamination may be possible. So hair stand, first day, you got hair in the product. In the second batch, plastic film was there. Number of packets affected. Who has who is the in charge for that particular shift? Okay, different types of problems have been identified across the different shifts and different dates, right? You can count hair problem, how many times hair problem is there. I told you, right? One, two, three times means one, two, three times. You need to draw it like this. Plastic, one, two, three times plastic problem is there. Fiber thread, two times. Like that, you need to make the check sheet. Here, see, I told you hair strand, three times. Frequently occurring, you need to make it in the beginning. Plastic films, three times. Fiber thread, two times. Dust particle, single time. Right? Somebody has raised the hands. Baradiran. Baranidharan. Yes? Yes, please. Baranidharan. Do you have any doubts? Baranidharan.
I guess it was by mistake, sir.
Okay then. Right. See here, like this, you need to give the tally marks, right? Then you can count if you are counting this one or not. It is least importance is given to this particular frequency. From here you can get easily. Fourth time means like this. Fifth time slanting line. Again you will start like this. Okay. In the industries, basically to track and analyze the frequency and type of foreign matter contamination detected during the visual inspection. Okay, for the period of 1 week. Then how do you interpret? Since you have identified that 3 times this hair problem is there, total number of frequencies 3, right? Hair stand contamination occurred most frequently 6 times, followed by the plastic film 4 times. How this 6 time and 4 time? You have to go here. Hair stand 1 plus say the second one 2 plus here hair stand 3 times. 3 plus 5 2 plus 1 total 6 times. Plastic contamination same thing. 2 plus 1 plus 1 total 4 times, right? See here you have to add each and everything. What is the number that you are getting? Number of packets affected over a week 1 3 4 6 7 8 11 12 13. 13 packets affected. Out of 13 packets, this one is 6. Hair strand is 6 plus plastic 4. Just imagine 10 divided by 13. How much percentage? More than 75% of the problem is because of these two things, hair strand and plastic film, especially for the biscuit production line. Okay, like this we need to interpret these two issues together. 10 out of 13 incidents, so total 77% is the very big cause. So these two things has to be properly maintained. This pattern suggests inadequate personal hygiene or poor use of the protective headgears on the packaging line, right? These are the some kind of conclusions you can draw by using these check sheets. These check sheets help visually identify the most recurring problem. Okay, most recurring problem type, which can later be represented in the Pareto chart to prioritize the corrective actions, right? These are the two examples for the check sheets. The next one is histogram. The next tool that you are using will be the histogram, right? What do you mean by histogram? It looks like this, right? So there are a difference. There is a very huge difference between histogram and bar chart. Bar chart looks like this. You should not get confused, right? Whereas histogram looks like this. Okay, there is no gap between the bars. But whereas in the case of bar charts, there is a gap, right? So here in the histogram, it's a graphical representation of the data distribution, right? It's a graphical representation, identifies the variability and patterns. What is the pattern? Suppose, for example, if you have, so many different types of sample are to be tested, you will get the, plots like this. And like this, say, suppose, for example, it is following some trend. Initially, it is increasing. Then slowly it is decreasing, right? Then what you will do to identify some kind of issues, you will divide your data into groups. Say suppose for example, this is 0 to 10, right? From here to here, 0 to 1. This one is 1 to 2, 2 to 3. Like that, 9 to 10. You will have a groups and you will find out how the data is behaving, right? So under each group, so 1 to 2, what is the area it is covering? 2 to 3, how much? So in this way, you can easily identify the variability and pattern. You can create a pattern, right? So like this, see here, it has come like that. One example, a small example I have given here, you can see moisture content variation in floor samples. Okay, you have any wheat flour or any kind of maida, or if you are dealing with milling industry, you will have a you need to handle flour, right? This is the raw data collection. This is the raw data collection from a flour mill. Okay, so here you can see how many samples they have identified. 1 to 50 sample. It is like this. Okay, to show you people clearly, I have made in this way. Okay, so normally it goes in a vertical, this one column wise, right? For the first sample, 10.8. Slowly, what is happening? Storage means definitely there will be an increase in the moisture, right? Based on the humidity condition in that particular flour mill surrounding area, the humidity is very high. Slowly, what is happening? They have identified there is a huge, there is a significant increase in the moisture content. You can see the initial point is 10.8 moisture going to 14.1. Definitely, there is a serious issue either in the uh, uh, you know either in the packaging. There is an issue with the packaging, or there is an issue with some kind of environmental issues will be there, because the deviation is there, right? So we need to identify what is the cause of this particular moisture increase. So how we can do this one? You have to group it. I told you, right? Group 1, group 2, group 3, group 4. Different groups have been created. Different groups have been created, right? It is your wish, 10.8 to 11.2 or 10.8 to 11, or how you want to make the class intervals. You can decide yourself, right? So if in this particular frequencies, you can see the histogram appeared like this, right? In the first frequency, you have two samples are falling here. Number of samples, frequency, and then the moisture content is like this. 10.8 to 11.2, in this range, two samples are falling. Whereas 11.3 to 11.7, four samples. Slowly, this is increasing here. See, between 12.8 to 13.2, right? In this particular section, the number of samples are 14. So in this way, you can identify in which range. Suppose, for example, you think this range is okay for me, I can tolerate, this is fine, but I cannot tolerate these two things. Then you need to identify, in order to keep your sample below 12.2, what you have to do, right? Those things you can get from this histogram. Interpretation, see here, how can you interpret? The histogram shows a bell-shaped curve, right? Distribution with a peak around 12.8 to 13.2. This one, 12.8 to 13.2. Here you got a maximum peak here. Most floor samples, 14 out of 50 lies within this range. Means slightly above the target mean. The target you have, okay, till 12.5 is my threshold limit. If it goes beyond 12.5, then I cannot accept. Okay, if you are giving this floor to your customer wholesaler, then he will have certain specification, right? Your floor should have moisture content. He will tell his quality control team to check the moisture. Why? Because moisture content is directly proposed. If more moisture content means more spoilage will be there. Directly proportional to spoilage, right? So that's why if you have this particular limit 12.5 as the threshold limit, then you need to identify, okay, what is happening with my sample? 14 out of 50 samples are more than 12.5. A few samples on the right tail, 13.8 to 14.2, this way. 13.8 to 14.2 is the right tail, right? Exceed the upper limit of 13%. You have The upper limit, mean is 12.5, upper limit is 13, lower limit is 12. You are okay with this. Still you are okay with this, but not up to more than this one, right? So in this way, you can interpret indicating moisture control inconsistencies in drying or packaging. I told you, right? In the drying or packaging, there is some issue you need to take care. This suggests a process variation issue. It may be due to inconsistent drying temperature, may be possible. Variation in raw wheat moisture, yes, that is possible. Improper sealing duration during the storage time. These three things are possible. Now what you will do, you will go back and check the dryer temperature. If it is fine, then what you will do, you will do the variation in the raw wheat moisture. Then you will check with the improper sealing, whether I am sealing it or not perfectly, or the package, is there any problem with the packaging material. So in this way, you will identify the issue using the histograms. The next quality control tool is Pareto chart. So as I already told you, Pareto chart is nothing but based on the 80-20 principle. Few causes lead to most problems. You have very few causes. In our lives also, only 20% of the problems will disturb us. It will take consume our 80% of the time, right? So we need to identify what are these few causes, and then we need to solve this particular problem, right? Helps prioritize the corrective actions. You can prioritize. If you are identifying what are the 20% causes that is disturbing you, then you can identify the corrective actions for those things. If you fix this one, then 100% is not possible, but still you can fix the entire problems, right? Example, identifying major causes of the problem rejection. Why the products are being rejected. Here I told you, right? Three different problems are there. How do you identify? There may be one. Okay, because of this, 80% of the problems. Because of this, only 20%. Drying temperature is fine, but there is a huge variation in the raw wheat moisture calculation. So what do? You will fix this one. You will fix this one. Okay, if you fix this one, 80% of the problem is solved, right? Remaining 20% you can easily fix by just adjusting the drying temperature. Here also same thing. The Pareto chart looks like this. It has two y-axis with the one x-axis. Types of defects, frequency versus cumulative percent. The cumulative percentage you have to identify. We'll see how to do that one, right? By using a very small example, defects in a bottled fruit juice production, right? So in the bottled fruit juice production, we need to identify defect. What is the objective for our particular problem? To identify and prioritize the most frequent type of packaging defect. You should have an objective to solve the issue, right? You cannot superficially tell these things may be possible, right? You should have some kind of problems. Okay, this I want to identify the most frequent types of packaging defect occur during the fruit juice bottling and sealing. This is the area I'm considering, not any other thing, right? So corrective actions can be focused where they have the most impact. So data collected over a week. So this is the, you can say this as a check sheet, right? You have taken a small check sheet because types of defects are there in the check sheet, right? Similar kind of check sheets you will take. Leaking caps, improper label placement, air bubbles in the juice, low fill volume, bottle cracks. These are the most common types of defects that occur in the bottle plant. Okay, juice processor. How many times? Frequency, you need to know the frequency, right? Number of occurrences. How many times it has occurred? Problem A. It occurred 45 times. B, 25 times. Air bubbles in the juice, 15 times. Low fill volume, 10 times. Bottle cracks, 5 times. Like this, you will study the number of frequency. Okay. Then arrange data in the descending. Like this, you need to count, because in the Pareto chart, you need to go with the cumulative percentage, right? In order to plot a graph. Types of defects. I told you, right? In the first check sheet, you can derive, you can interpret, possible solution from the check sheet. Then you can go with the Pareto chart for identifying what types of defects, right? So here, leaking caps and frequency is already given. You will get the cumulative frequency. Okay. So to calculate the cumulative frequency, okay, you need to do first 45 will be there. Out of 100, you need to calculate, right? So what you need to do, accordingly, you will calculate the frequency, cumulative percentage frequency. Okay. So here, if you see the Pareto chart, you will get it like this. 45%. 45% means cumulative percentage. Cumulative percentage is, frequency is 45% here. Okay. Then in the second one, 70%. 70% cumulative. Because this is coming in the y-axis. Types of defects are coming in the x-axis. Types of defects are coming in the x-axis. And then you have this frequency. How many times it happened? 45 times, 45 times, 25 times, right? So in this way, you have to do this Pareto chart analysis, right? So the next one is interpretation. How do you interpret is the main question, right? How do you interpret? See here, Pareto chart, I told you from the check sheets, you can draw the conclusion, and then, you can draw the conclusion from the check sheets, and then you can connect that with the Pareto charts. That's what I told you, right? So here you can see 45% problem is because of the leaking caps, likely due to improper torque or defective sealing heads. You will again go back to the unit and you will check why these leaking caps are happening. Leaking caps means there is something wrong with the sealing heads, right? Something wrong with the sealing heads. The second most frequent issue. What is the second most frequent issue? Around 25%. Here, if you see here, around 25% problems are because of improper label placements. Initially, what you need to do, you need to identify, 1 and 2, or maybe you can go up to 3, first, second, and third, most dominant defect for solving. Remaining things you can easily identify. Am I correct? See here, one thing I forgot to tell you is cumulative frequency. That is, for first one is 45, okay, whatever is there, the frequency it has. How 70 has come? How 85 and 95 or 100 has come? See, same thing we are representing here, right? It's very important. If you add both the things, 45 cumulative frequency, right, plus 25, this error plus this error, both combined together 70. 50 plus 70. This error and this error both combined together comes 85. This and this 95. If you add, you are accumulating each and everything. If you add last two, then 100% errors will be solved, right? So why? Because we have only 5. 1, 2, 3, 4, 5. In the industry, if you go, it may be 10 or it may be 20 or 30. Accordingly, you need to calculate the cumulative frequency to solve 100%. Maximum whatever defects are there, you can try to solve this one. The second most frequent you solve, right? Similarly, the third most frequent, because together it is 70. And the third one, if you see, this is very small, 15%. Even this is small. If you are okay, satisfied with the 95% cumulative frequency, you can ignore the bottle cracks, because only 5% error is okay for us, right? So in that you have to take the decision. This one more thing, these tools will not give you the solution. These tools will give you the idea what are the defects and where are the defects, and you have to derive the solution out of this information available. Together these two defects cause most of the rejections and rework. So corrective action should be prioritized there first. I told you, right? The corrective actions should be prioritized for these two types of defects, 45 and 25. What are the applications of this Pareto charts in the industry? You can see in the packaging area, you can use leaking pouches, missing labels or improper sealings. In the processing area, you can use, and then in the quality inspection area and in the maintenance area also, you can use this Pareto chart, right? Especially in the maintenance area, you can see machine downtime causes and stoppage frequency. These two things are very much important when it comes to maintenance. Why? Because if suppose, for example, take any machine, if the downtime is 10 hours, just imagine how much quantity of raw materials are not being produced as the final product. Am I correct? You are stopping the production, right? For 10 hours, if you stop, that's why you should have a plan B. Okay, maintenance days will be there once in a month. Okay, so like that, these industries work very cleverly. Okay, and it has to be there. They use these QC tools. These are very simple tools. If we learn all these tools, then definitely it is add-on for us. The next one is Ishikawa diagram. What is Ishikawa diagram? Ishikawa is a Japanese scientist. He invented this particular fishbone or cause and effect diagram, right? To solve or identify. You cannot solve, but you can identify what are the problems, right? Categorizes this particular cause and effect diagram, categorizes root causes under man, machine, 5M. 5Ms will be there. See, man, machine, method, material, measurement, and mother nature. 1, 2, 3, 4, 5, 6. 6 M's. Sorry. 6 M's will be there. Right. It is called as the fishbone diagram. It looks like fishbone. It looks like a fishbone. Here you have effect. What is the effect? What is the problem that you have? Okay, here you have 6 M's. M, man, machine, method, materials, measurement, and mother nature, right? These are these are 6 things under which you have subdivisions also. How many subdivisions? You can primary causes and the secondary causes. You can call it like this: primary causes, primary cause, and these things are secondary cause. This is not limited again to the secondary cause. You may have tertiary cause, right? It can go up to 4, 5, 6 different things depending on the complexity of the problem, right? These are the causes. This is the effect. This is what you are going to solve. Used in troubleshooting process deviations, right? One example I brought here for you people. Cause of leaking caps in bottled fruit juice production. Again, the same bottled fruit juice I have taken. What is the objective of this particular problem is to identify the possible root causes. If you see previously, it is not identifying the possible root causes. Am I correct? Based on the technique, based on the tool that use, the objective will be made, right? Behind the high number of leakage caps found during the quality inspection in a bottled fruit juice manufacturing line. Identify the major causes, cost category: man, machine, method, material, measurement, and mother nature. Normally begin. Otherwise also 6 P's are there, right? Different people use it, use different causes, right? See here, first what we will do, we will do the brainstorming, right? Brainstorming possible causes. What are the possible causes that are coming? You have a quality control team with you. Everyone will sit together and you will do the brainstorming. Under man, you will ask the people, what are the causes can come under man? So one by one, people will say, right, inadequate operator training. Maybe we did not give proper training, right? Or capping torque. Negligence during visual inspection. Maybe this is possible. Then fatigue during long shift. If you are allowing somebody to work longer during 12 hours, 14 hours, then definitely his or her efficiency will come down, right? He'll start ignoring so many things. So in that way, we have to identify these are some of the possible causes. Man, under man. In the machine, you see, what are the possible causes? Worn out capping heads, improper torque setting, air pressure fluctuation in the pneumatic sealer. See, there may be many, but I have given three different types. Right? Three under each and every cause. Method: incorrect bottle alignment procedure, inconsistent tightening, or maybe lack of standard following. See, you can use this particular cause and effect diagram for any kind of problematic solution. Suppose if you are not scoring well in your exams, right? You can make this particular cause and effect diagram, right? Your effect will be what? Your effect will be not scoring expected marks, right? Under that, each and everything you will, try to make the causes under the man. You will write, maybe you are not frequently studying, or maybe you are not following the classes, you are you are bunking the classes, or maybe you fall sick. So these are some of the possible causes coming under the man. To make it easy, I'm explaining you like this. In the machine, right, you bunk the classes because of you do not have petrol in your vehicle, or you are using cycle puncture, whatever the machine related causes, you will give it here. Method: you are not properly following the textbooks or properly following the methods that is required for your study. Material, like that, each and everything you can derive possible causes under each this one, right? Causes. Okay, I think I am clear. All right. So in that way, in the material also, you have to derive the possible subclasses. These are what? Secondary causes, right? In the measurement also, no torque calibration, inaccurate torque testing device. In the mother environment, you have high humidity. Here in the mother environment, you fall sick because of rain. You fall sick because of whatever the reason, you will put it like this, right? And dust contamination near the capping area. This is also possible. Since we are discussing the bottling plant, we are doing like this, right? This is the possible. Then you have to prepare. Okay, these are possible causes. Then I will draw the fishbone diagram. If I draw the fishbone diagram, it looks like this. Leaking caps in the bottle juice is the main effect, right? This is the effect. These are the causes. You can see these causes are aligned with respect to man, mother nature, material, method, machine, and measurement, right? So whatever we discussed here, the same thing, inadequate operator training, same thing, inadequate training. And then next is operator fat is this one fatigue, right? Same thing, operator fatigue. You need not to write the entire sentences. For your understanding, if you can write 1 or 2 words, that is sufficient. This is very small fishbone diagram I'm discussing with you people. In industries, if you see primary, secondary, okay, even there will be more causes also. We are discussing 6 common causes, but it may go up to 8, 10 or maybe 20 also, right? Especially in the manufacturing sector, the causes are very high. Okay, for this particular effect, how many causes will be there? You need to identify. Again, you will have subdivisions in the secondary causes like a tertiary causes. Okay, so in this way, you have to build the fishbone diagram to identify. So where I have to check, suppose for example, defective bottlenecks. Okay, I have to check this particular point. Poor cap quality, I have to check this one. Cap linear variation. Okay, this is happening good. And then you will cross. Okay, this particular thing is okay. Dust contamination. No dust contamination is there. Okay, fine. Air pressure variation. There is no air pressure. Okay, fine with this. Whatever you have to, there is no proper temperature control is there. Then temperature variation, you need to take it seriously. Similarly, no leak testing, right? So like that, you will identify what are the different important possible causes. Then you will list it down. Then you will derive for the solution. Okay, for this, what I can do? I can do, temperature sensor I can place, or maybe thermostat I can place in this particular area to measure the temperature, to check the temperature, right? So in this way, you can do the fishbone diagram easily. This is the interpretation. The fishbone diagram clearly maps all potential causes. See here, you need to understand this fishbone diagram is used for the potential causes, right? Potential causes means it may occur. These are the causes, potential, contributing to leaking caps. Root causes may be like, what are the root causes here? Improper torque setting, you identified. Untrained operator as the root cause. Poor cap material can be root cause. Right. Once these are verified by the inspection or trial team, corrective actions can be implemented. Right. So this is how you will do the cause and effect diagram. The next quality control tool is control charts. Right. What do you mean by control chart here? Plot process data over time against control limits. Detects trends, shifts, and out of control situations. Examples are something like this: pH or viscosity tracking in the sauce production. Okay, so here I have given one small example for this particular control charts also. Monitoring the net weight of potato chips packet. Monitoring the net weight of the potato chips packet. What is the objective? To monitor and ensure that net weight 50-gram target is set for the potato chip packets consistently remains within a acceptable limits over the time, and to identify any process variation or assignable causes. Right. This is the data collection. You can see, sample numbers. It is 10 samples have been taken. In the first sample, again, you have multiple packets you have taken, and you weighed 49.8, 50, 50.2, 50.1, 49.9, like this. Then you took the mean of this particular sample one, and you calculated the range also, ranges. Okay. Similarly, for how many different samples you have identified here, total 50 samples you have collected, you weighed, right? Under this category, okay, 10 samples are different. Okay, anyhow, 50 samples you have taken. You collected the sample means here, and you calculated the range also. Then if you plot that one, the graph looks like this. Okay, if you plot it in the Excel, the graph looks like this. Okay, you have sample mean, X bar is there. This is the X bar for sample 1. Okay, So it is like this. Sample 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total, you have 10 samples. Right? 9 and 10. It's correct. Total 10 samples you have. So each sample, you took the mean 50 and then you plotted it. Okay. For this particular sample, this is the upper control limit. This is the lower control limit, right? For this one, you have upper control limit and lower control. This particular one, you can see 49.8. 49.8 is the mean, right? This 49.8 is falling in the lower critical limit. If you take the upper critical limit 50.2 and LCL is 49.8. Similarly, for 3, it is falling here, upper control. See how much variation is there in the data. Right. So this is how you do the control charts. So how to interpret this particular control chart? All sample means lies within the control limits. What are the control limits? 49 to 50.2. 49.8 to 50.2. These are the limits. Okay. So what do you mean by this? These are the limits. If I give you 50 grams of potato chips, right? You will weigh it. Exactly, you will not, get the 50 grams, right? It may be 49.8 or some standard deviation will be there. Plus or minus. Some value will be there, right? 0.6 or 0.4 or 0.7, whatever it may be, the standard deviation. Basically, variance in the data, right? If as a customer, I will tell you, okay, if the potato chips ranging between 49.8 to 50.2, okay, I will accept. No problem with me. If it is 47, then I will reject. If it is 53, as a customer, I will take because I'm getting more, here. But for the company, 53 grams instead of 50 means 3 grams extra is giving at this low cost. So for company, it is not profitable, right? In this way, you have to check what is the upper and lower critical limits. Since all the points are falling under the UCL and LCL, okay, this is in the controllable limits. The process is under control. However, there is a slight downward trend occur in the sample 7. Yes, there is a problem with the sample 7. From here, you can see downward trend is like this. It is going beyond the lower control limit. The lower control limit is 49.8, but for the sample 9, you see, it is coming below. So it is not acceptable. Possible due to filler calibration draft. Maybe some some problems will be there. If any sample mean had exceeded the UCL or LCL or shown 7 consecutive points trends upward and downward, it would signal a specific cause needing investigation. Yes. If this is the scenario, this sample 7, sample 8 and sample 9 need thorough investigation. Right? What is the problem? You can easily tell by doing the analysis of these 3 samples. The next tool is scatter diagram. Right? It shows the correlation between 2 variables. Correlation between moisture control and microbial count relationship is also possible. In the scatter diagram, relation between frying temperature and oil absorption in the potato chips I have shown. What is the objective here? To determine whether frying temperature affects the oil absorption in the potato chips or not. Right? These are the data collected from the industry. Frying temperatures 140, 145. These are the frying temperature. Oil absorption. At this particular temperature, the absorption is 32%. At this particular 30. As it is, the temperature is increasing, the oil absorption is declining. This is the trend that you are observing here, right? If you plot this, you will get the graph like this with respect to temperature and oil absorption. Right? For the first sample, okay, at 140, the oil absorption is 30. For the 145, the oil absorption is 30. 150, 28, like that. If you see, there is a declining graph. If something goes wrong, suppose for example, for 160, you got 30 value. For 160, your value is 30. If you get here, then you will get a graph like this. Am I right? Then you can identify this particular point. This sample has something, some problem, right? Because it is not showing a trend. Okay. You know that, frying temperature and the oil absorbance have some kind of correlation. If it is not following, then there is some problem with that particular sample. Again, you need to go back and do the frying process. Okay. So that's how you will use this particular tool. It's called as the scattered diagram. Similarly, microbial count also. In the microbial count, if I ask you people, if the moisture is 5%, low microbial, right? 1 log CFU, 1 log CFU. If the moisture is increasing, 6, 7, till 50, if it is increasing, the log cycle will be increasing. You will get a 7 log CFU, which means if you draw a graph between moisture, microbial count, right? Microbial count versus moisture, right? So in the moisture, if it is 5, 5, 6, 7, 8, 9, like this, 50 are there, right? 5. For 5, it is 1 log CFU. 1, 2, 3, 4, 5, 6, 7 log CFU. 1 log CFU. For 6, you got here. For 7, 8, till 50, you are getting like this. So it is following a upward trend. Linearity is following. If something goes wrong here, suppose, at this particular moisture content, maybe suppose for 10, the log CFU is very less. Maybe you are getting here. Okay. Then there is a problem. There is a problem because the graph will be like this. This is how you need to identify where is the problem in our data. This interpretation, as temperature increases, oil absorption decreases. Points slope downwards, negative correlation. Yes, we identified this as negative correlation. In the case of moisture versus microbial count, it is a positive correlation, right? Positive correlation means increasing trend. This means higher frying temperature reduces the amount of oil absorbed in the chips, beyond which temperatures 185 chips may burn or darken. So that is the practical limitation. The last tool here is flowchart. What do I mean by flowchart here? Normal stage, a visual representation of process steps used for process mapping and identifying the critical control points, right? Suppose for example, if you are going with any flowchart, okay, say suppose for example, jam preparation or maybe jelly preparation or whatever, jam preparation. First, what you will do, you will take the raw material. You will take the raw material. Then you will write the flow chart, right? Then washing. Before that, if you want, you can add sorting and grading, washing, then peeling, right? Then you have different process steps are there till you get the packaging, right? So if you do any process, you will do the process flowchart. Why process flowchart is important? Immediately you can decide what is the next step. Okay, I have to peel it after washing. If you're not doing this one, some people may get confused. They will peel it, then they will wash or whatever. Something will go wrong. See here, like this. If the process have continuity, it will be followed. Okay, if there is no continuity, then we cannot follow the flow charts. Okay, so in that way, flow charts are helpful. Some of the advanced quality control tools, if you combine two different tools, then you can get some kind of identification problem solving, right? Histogram analysis, automation, you can do that one. Box plots, heat maps, multivariate trend analysis, statistical process control software. Yesterday in the yesterday class, you learned this one, right? Statistical process control. You use SPSS or design expert or whatever integration with the SPS software. That is the some of the advanced quality control tools. In the statistical quality process control, you can see identify the process. These are some of the steps coming under SPS. Determine the measurable attributes of the process. You will identify the process, then you will determine the measurable attributes of the process, determine the measurement method, what method you need to use for measuring, then collect the data and plot the charts, then monitor the process variation. Uses statistical methods to monitor process stability. Some of the parameters, mean, meridian, variance, standard deviation, all these things you can consider. Basically, it reduces the waste and improves the consistency, right? The waste elimination is very much important when it comes to quality control. That's what the Six Sigma principle says, right? Yes, next one is Six Sigma. Six Sigma in food analysis. What is Six Sigma here? After point, right, 20 means you will consider 2, 3, 4, 5, 6 like this. 1, 2, 3, 4, 5, 7 points. Okay, like this Six Sigma means for the standard deviation. Okay, 6 points. Suppose for example, how to interpret that one? If you have less defects per million opportunities, right? So 3.4 defects per million opportunities called as the Six Sigma principles. It's not necessary that you have to use Six Sigma. Okay, 2 Sigma is fine, 3 Sigma is fine. Depending on the process, you can decide. Okay, because most of the companies, they follow Six Sigma. It doesn't mean that for food industry also this will be applicable. Yes, it can be applicable, but these many defects may be more. Okay, because of that, you have to consider less sigmas. Less sigma means more defects can be acceptable. Sometimes some companies accept 4 sigma, some company accept 5 sigma. Okay, like this you have to. Basically, this Six Sigma works on this methodology, DMAC cycle. What is DMAC cycle? Define, measure, analyze, improve, and control. Right. This is the key of this Six Sigma. This is a data-driven approach for defect reduction. And then quality management systems. What is quality QMS? You learned, right? PDCA, plan, do, check, act. In the Six Sigma, you have DMAC cycle. Okay, the number of defects acceptable are 3.4 defects per million opportunities. We have learned this one, right? In the testing laboratories, we have learned 17,025, 2017 ISO standards, 9,001 is quality management, and 22,000 is food safety management. Well, so you have, certain QMS, quality management system in food industries. So according to your needs, you have to follow. If some people are working in food laboratories or food testing laboratories or accredited laboratories, then they should know more about this particular ISO standard. This is common. Okay, this is applicable for all the kind of industry under which you have different categories. So calibration and standardization is also very much important. In the last class, I told you how the calibration is very much important. Suppose, for example, if you are measuring any even small weight of the sample, right, before doing the food analysis, in the analysis protocol, it was said that 5 grams of the sample to be taken, and you need to do the methanolic extraction using this much percentage of methanol. Okay, so in that way, if your weighing balance is not calibrated, instead of 5 grams, okay, unknowingly you are taking 7 grams, then what will happen? You will get whatever the molecule you are detecting, you will get in a higher concentration. Am I right or not? If it shows less weight, accordingly, the concentration of your target sample will be less. That's why the calibration and standardization of the process, standardization of the product is very much important. What is the difference? In the calibration, you will do calibration for equipments to get the same results again and again. In the standard, you will standardize the product to get the same results again and again, same texture again and again, same sensory attributes again and again, right? So that's why both the things are very much important. Regular calibration ensure instrument accuracy. Use certified reference material. CRMs are important. Document control for traceability. Calibration is the process by comparing an instrument method against a known standard to ensure its accuracy and can involve adjustment. In the case of standardization, is a process of establishing and following uniform procedures for using and maintaining instruments to ensure the consistent results. These are the two different things that we need to remember. The next one is documentation and record keeping. In the ISO says this is the last point in the ISO, right? In the principles, if you see, this is the last point. What is the last point in documentation and record keeping? Even in the HACCP principles also, HACCP principles, what is the last, seventh principle? Documentation and record keeping is very much important. This will help you in traceability. If some external auditors are coming, then they can have access to your record. They can easily, identify or maybe, get a picture about, okay, whether this particular process is okay or the product is okay. They will get some kind of information, right? That's why the documentation and record keeping both are very much important. Okay, the next one is the documentation record keeping includes the standard operating procedures, calibration logs, quality control charts, and all the certifications that a company is having, right? So in the records, you can have identifying the transactions. Okay, if you are making some kind of transactions, that everything, not only the transaction details, but whatever the control charts I've discussed, those things also, it should be documented properly, right? These are the financial terms. You need not to go through this one. Recent advances in food analysis. Yes, we discussed these things in our earlier classes. Ultra high performance liquid chromatography, UHPLC, right? We had HPLC, and this is the new technology, UHPLC, gas chromatography, mass spectrometry, and then you have liquid chromatography, time of flight. These are some of the advancements are coming into the analytical fields. Once it is available, we'll know what is this one. Yes, the biosensors also very much important. Biosensors, what it does, suppose for example, it looks like this lock and key mechanism, especially if you see the glucose sensor. How do you identify the glucose? You have target and bioreceptors. The glucose molecule will go and sit onto the bioreceptor. Then you will get a signal how much quantity is present in this particular sample, right? This is portable biosensors, rapid. You will get a and biosensors like so many biosensors are there. Tags, some tags are there. Okay, it will give you a rapid estimation, and then sensitive detection systems. For the sensitive detection systems, also you can use used for pathogen, pesticide, and allergen detection. Okay, basically the mechanism will be like this. Spectrometric advancements also there. We discussed those things. FTIR, okay, Fourier transform, infrared, Raman spectrometry, for rapid compositional analysis. Okay. Then NIR means near infrared. Okay. So for non-destructive food quality testing, right? In the earlier class, you learned about non-destructive food quality testing, right? The next one is hyperspectral imaging or multispectral imaging is very new concept. Using the images, you can read what is the quality of the product. You see here the difference. This is the Raman spectrometry. In the Raman spectrometry, you will get a graph like this. From this graph, you can identify what type of compounds are being absorbed at which location. Those things you can easily identify. And of course, AI and ML are integrating into each and every manufacturing unit. Even for the analytical labs, also this AI ML is also integrated. Pattern recognition in spectral imaging, chromatographic data, predictive modeling of shelf life and quality trends, automated anomaly detections are also some of the advancements in this particular field. And yes, IoT is also important thing. Most of the people know about the IoT, right? Internet of Things. Basically, what it does, it gives you the real-time monitoring by connecting the sensors. There are so many sensors are there in the UNO Arduino chips. You can connect these sensors. You can quantify what type of samples are present in your, what type of compounds are present in your sample. Data integration with cloud platform. Okay, that is also possible. You can integrate the data with the cloud platform using the Internet of Things, right? Using the Wi-Fi module. You can share your data to mobile or tablet or PC. What are the application? Cold chain. In the cold chain, you can use storage quality and then contamination alerts also you can make it, right? In the contamination alerts, I will tell you one example. Juice. Okay, if the juice is fermenting or not, using just by using an alcohol sensor, okay, or maybe the CO2 sensor, you can identify the contamination of the fruit juice. And rapid microbiological methods. What is rapid microbiological methods? ATP bioluminescence. You just take the swab and go with this ATP bioluminescent kit is available. You just put the swab, you will get the reading, right? Reduced incubation time and high accuracy. This, see, nowadays in the fast world, all these results should be very fast. Okay, just like oven method for moisture estimation, you require 2 hours. Nobody has 2 hours to estimate the moisture, right? Just give your sample within 5 minutes, you get the result. Similarly, for all other analytical equipments also. That is the advancements happening in this particular analytical field. Used for hygiene and pathogen detection. Pathogen detection is also very much important. Non-destructive testing, right? In the non-destructive testing, you have NIR spectroscopy, X-ray imaging, acoustic methods. Acoustic method means using the sound. Okay, something like ultrasound or any kind of sound at different frequencies. You can use those things, and you can get information how much sound is being absorbed by that particular material. Using different detectors, you can do that one, right? And then real-time quality assessment without sample loss. This is also very much important, right? You can see this example here, how the spoiled fruit looks like in the X-ray, right? Based on the images, you can easily collect the data and you can make a model, generate a model, and you can identify this kind of fruit. If it has this characteristics, then reject. Okay, in the grading and sorting system, you can easily use this particular method. In the nanotechnology and in the food analysis also, you have nanometric based sensors which enhances the sensitivity, right? Most of the nanotechnology is used in the food safety and food preservation aspect. Antimicrobial agents, nano encapsulation is possible, used for detecting the toxin and pathogens. And data management and automation, I told you, storing the data is very much important. If you are working in a central labs or referred FSSA referred labs, the data storage is very much important. You cannot manipulate the data. The data storage and sharing is also very much important. Reduce transcription errors and ensures the traceability. In the last class we discussed about laboratory limbs also, to store the data, right? Management system, laboratory management system. Automation in analytical labs. Yes, robotic sample preparation. Sample preparation is very much tedious, right? For GCMS or HPLC or whatever the analytical equipment you take, the sample preparation is an Herculean task. If you are not preparing the sample properly, then you will end up with wrong results, right? Which is of no use. So a robotic sample preparation is also coming up. Automated pipetting and plate handling. In the GCMS, I don't know how many of you people saw, in the GCMS auto injector is there. Right? It will take up the sample and it will inject automatically. Earlier version, in the HPLC video demonstration also you saw, right? In the injection 20 microliter is taken and it will be injected manually. You need to hold it straight. You should not bend the injection. It will break. It will have a lot of contamination. All these errors can be eliminated if you have this auto pipetting or auto plate handling mechanism. In the GCMS, this particular arrangement is there. Increase throughput and precision, right? And then in the green analytical chemistry, what is green analytical chemistry? Using the green solvents for extraction. What are these green solvents? Okay, these green solvents, something like, which will not harm our body, non-toxic, safe, or from the renewable sources. Okay, so those kind of solvents you can use. Reduce the replace and recycle solvents and reagents. Emphasis on sustainability and eco-friendly analytical methods. See, this particular thing, green analytical chemistry is useful with respect to sample. Minimum number of samples are required and size is required. Reagents, non-toxic reagents are required. Instrument, efficient instruments. Method, automated methods. No sample treatment, no derivatization is required. Waste, reduced volume of waste. Operator safety will be ensured if you are using green analytical chemistry. Again, the blockchain technology is there for used for the traceability purpose, right? So what do you mean by traceability? We learned that one in the earlier classes also. For take an example of shrimp farming. Shrimp spoilage will be there, right? In the shrimp farming, for starting from the harvest in the fields, they see where it is traveling, what is supply chain, which path. Each and every junction you can use the blockchain for tracing how it is going. Right, this is an example I'm telling, because basically it secures data sharing across the supply chain, prevents the fraud and ensures the authenticity. Right, here in the example, see farmer A, he produces tomato, he gives to the delivery company, transportation is happening, then ultimately it is ending up with the sauce. Transfer ownership from A to C. A to C. Okay, smart contract will be signed, right? Some blockchain management will be done. Once the product is sent, automatically the money will be credited, or maybe the specifications will be shared, right? You need not to worry. Everything is automatic in the blockchain, interconnected. Smart packaging and embedded sensors. So you must have learned about the smart packaging, right? Intelligent packaging. Okay, some RFID detectors are also used for predicting the real-time changes in the fruits in the packaging material. Same thing. This is also smart packaging with embedded sensors, real-time monitoring of freshness and spoilage of fruits and vegetable or any food product, indicators of gas, pH and temperature, right? Ethylene gas production, or maybe any pH change is happening. So all these things you can. Then the next advancement is 3D printing and food analysis. Custom designed food structure for texture and nutrition studies. Okay, this 3D printing is being used everywhere, not only in the manufacturing field, normal manufacturing, mechanical application, but for food industries also. 3D customized 3D printed products are emerging into the market. Okay, customized 3D products, it will help us for diabetic people. If low sugar is required, you can custom make, right, this particular product in whichever shape, whichever way you need. You can easily print your product. It's a novel approach in this particular field. This is how it happens. Design, process planning. In the process planning, a set of automatic and manual operations for digital design has to be there, and then manufacturing operations will begin, and then post processing. So how you have to accept that particular product, right? So these things are very much important. Future skills need and research directions. What is required? Integration of data analytics and sensory science. We learned about sensory science, right? So many different types of sensory methods are available. Fuzzy logic is new thing. AI and ML, integrated sensory science, data analytics, all these things, integration will be the future. Need for interdisciplinary expertise. Okay, food technologists will work with mechanical engineers, electrical engineers, or any other. This interdisciplinary expertise is required. Focus on automation. Automation is the key, right? AI and sustainable analytics. Data integration is very much important. So that's it for QC tools and future trends in food analysis. Some of the key takeaways from this particular lecture, you can see you learned what are the different QC. There are 7 different QC tools are available, and under each QC tool, you learned one example, right? How to do that one, right? How to use that particular tool to identify a problem and to uh, you know predict, or maybe to solve, how to solve that particular problem we found by using QC tools, right? And then emerging technologies. What are the different emerging technologies that ensures the accuracy, precision, speed, and sustainability? Then future of food analysis, we have seen it is nothing but digital. Everything is data analytic, data driven. Okay, everything is going digital. So we need to learn so those aspects in order to survive in the market, right? So these things are very much important. I've discussed the basics of the QC tools. If any one of you have any queries, you can ask me. Now the session is open for discussion. Anyone, any queries, any specific queries related to this topic, or related to our entire course, because we have concluded this particular course.
Kindly,
Yes.
sir, in 3D printing part, can you repeat one more, sir?
Nothing, sir. See, 3D printing, you already know, right? 3D printing using different, especially the 3D printer used for food application. It has feed materials. You can use protein, high protein materials for printing, right? Or maybe you can use carbohydrate polymers, right? For printing, cups, not degradable cups, or maybe, for the texture improvement. Okay, for nutritional improvement. Okay, you can use this 3D related, 3D printed food items just for customization purpose. Customization means for different age groups, for infants or maybe children, they require sweets or chocolates. You can design to that particular age group a new kind of functional chocolate by using 3D printer, right? So basically, what in the feed, what you will add, you will have carbohydrates, proteins, and fats with the different mixture. When it extrudes, you will get a product, right? So you need to put in the feed the right proposition, and the temperature of the nozzle also should be right to get the right this is nothing but extrusion mechanism only, 3D printing, right? So in that way you can use this particular 3D printing in the improvising the texture of the material. Some people, those who have issues with hard texture, you can design a product for those people by using the 3D printing, right? Any other queries? Anybody? So we have completed 20-hour lecture, 20-hour course, right? Starting from knowing the basics about the importance of food analysis, then slowly we move towards the practical demonstration. We learned about chromatographic techniques, spectroscopic techniques. Then you saw some practical demonstration. Then you learned about sensory evaluation, food additives, how to detect the food additives. You saw some examples also. You learned about quality management principles. You learned about FSSAI, food labeling and compliances with both FSSAI and Codex Alimentarius. I think we have covered all the aspects to fulfill the course objective. Okay, we have tried our level best to deliver the good content. Okay, if you have any doubts, you can ask me. Otherwise, also I can take the queries through WhatsApp. Okay, so without wasting our time, I request Divya Darshini to announce for the quiz. I request all the participants, since the quiz is very much important to get the certificate, I request all the participants to participate in the quiz. Okay, we have divided this particular quiz into two sections, right? Now we will be conducting, so those whoever is available, you can give quiz right now, or if you feel like you want to give in the second half, maybe 6:30, maybe at around 6:30 in the second quiz, you can also plan for that one. I think Divya Darshini will explain you.
Yes, sir. So thank you, sir, for that excellent and thought-provoking session on QC tools, recent advances, and future trends in food analysis. So moving ahead with the quiz, there will be a short 15-minute quiz session and we will share the quiz link. Participants are requested to attend the quiz within the time. Once the first quiz is completed, we will move to the valedictory session. So log in using your registered name and email ID only. Only one attempt per participant in any one session. Either you can go with the session 1, which is from 3:55 to 4:10, and session 2, which is 6:30 to 6:45 p.m. So the quiz will be conducted at two different times. I repeat, the quiz will be conducted at two different times. Participant can attend the quiz at their convenience. Only one response should be considered from each participant. I will be sharing the quiz scanner now, and give me 2 minutes. Is my screen is visible, sir?
Yes. The screen is visible, Divya.
I guess shall we show the scanner now, sir, or should we wait for time?
Yeah, you can show this scanner. It's okay. Only 4 minutes, right?
Okay, sir. So this is the scanner. You can scan the QR code below to access the quiz and log in using a registered name and email ID only. One attempt is allowed per participant.
And the link is also shared in the comment section. Okay, in the chat section, the link is shared. You can also access your quiz by clicking onto that link. Divya, you also please share this link in the WhatsApp group so that if anyone wants to access
Yes,
from
sir.
the
I will
WhatsApp.
be sharing in the WhatsApp group also.
Okay. All the registered participants, you are requested to give the quiz. Okay, without quiz, certificates will not be generated. Kindly give your quiz. There is a second chance for those who are busy or who are unable to give the quiz right now. It will start from 6:30 to 6:45. It will be shared in the WhatsApp group, right? Those who can do it right now. One participant, only one quiz is allowed. If you are attempting both the quizzes, then your candidature will be cancelled. Okay, that's why you don't attempt both the quizzes. Attempt any one. Use your name and email ID.
And the link of this quiz will also be shared in the WhatsApp group. Please check the WhatsApp group. Those who are unable to access this QR code.
Exactly at 4:10 we can start the validate session. Divya.
The quiz link is active now. Participant can start doing their quiz assessment. So the time deadline will be 4:10 p.m. So kindly complete within that.
Hello, sir.
Yes.
Sir, there is some problem with the link because we are not allowed like this. See, it is
Use your registered mail ID. Whatever mail ID you have given during the registration, you give those email ID and name.
Sir, after submitting the first question only, link get automatically submitted. I am unable to solve the second problem.
No, it is not possible like that.
Uh,
You type your
if you
queries in the WhatsApp.
yeah, if you are changing your screen while the quiz is on, it will be automatically getting logged out. So
Okay,
I
okay.
request participants not to change your screen
Yes.
and continue attending the questions, and after you attend all the quiz, then press the submit button.
Sir, so can we start it again?
No, you cannot do that. Hello.
This quiz assessment is for the students who are from the not from the NITR. So the NITR students, you don't need to take the quiz test now. So this quiz session is for the outside participant only. Participants are requested not to switch the tab between the questions, so it will be automatically logged out. So don't switch the tabs between going on the test.
Ma'am, but actually I did not switch the tab. I just tap on the next forward button only. After that, it directly that submitted screen appear on my screen.
Okay, please mention your mail ID in the group.
Yes, ma'am, I'm mentioning again. Ma'am, I mentioned my mail.
Hello, ma'am.
Yes.
Hello.
Yes.
Ma'am, after completing test, वो मतलब वो जो वो है ना, वो जो experience feedback is compulsory or not?
Actually, the validatory function will start soon, so please wait in the Zoom meeting itself. Don't exit the Zoom meeting. We will be starting the validatory function soon.
Okay, ma'am. Okay, ma'am.
Okay. So the participants, after completing the test, don't leave the Zoom meeting. We will start the validatory function in 5 minutes. Participants, there is no need to mention the participant. There is no need to mention the test completion uh, acknowledgement in the group. Just make sure that you have completed the test. There is no need to mention that in the group. And please don't leave the meeting. We will be starting the valedictory by 4:30 p.m. All are requested to mention mail ID along with their issue in the same message.
Piyush, shall we stop this quiz?
Those who have got the access for retest has been told to delete the browser history before reattempting. So I repeat, access has been given to those. Please delete the browser history before reattempting. Those who have attempted the first quiz don't attend the second one. It will lead to the cancellation of the course certificate. I repeat, those who have attempted the first quiz don't attend the second one. It will lead to the cancellation.
Divya, is Arun sir is there in the meeting?
Let me check, sir.
Otherwise, you call him to join. We will proceed with the valedictory function. Those who are doing the quiz, let them do.
Okay, sir, I will start the valedictory then. Arun sir is there in the meeting.
Okay, we can start the valedictory session.
Yes, sir. Thank you to all the participants for attending the quiz. Don't get panicked. There will be another session will be also there. So we have finally arrived at the most awaited part of our program, the valedictory function of 5-day workshop course on the food analysis and quality control 2025. I, Divyadashni, student coordinator and research scholar in the Department of Food Process Engineering, NIT Rourkela, feel truly honored. Truly honored and delighted to welcome you all virtually to this closing session as we bring this intellectually stimulating and scientifically enriching journey to a meaningful conclusion. Let me give you the summary of our certificate course. Over the past 5 days, we journeyed through every essential aspects of food analysis and quality control, from fundamentals to the advanced analytical techniques. Day 1 set the tone with the insightful lectures by Dr. Vivek Kamambati on the importance of food analysis in future industries, food industries, and Dr. Arun Prasad Venugopal sir on sampling techniques and sample preparation. The day concluded with a practical demonstration on proximate analysis and result interpretation by Ms. Divyadarshini. Day 2 took us deeper into chromatographic and spectroscopic techniques, followed by a hands-on demonstration session by Ms. Rashmi PK, which made the concept even clearer. On the day 3, we explored the detection of food additives, adulterants, and contaminants, as well as microbiological analysis of foods, and an engaging demonstration on rheological and thermal analysis by Ms. Subhi Singh. Day 4 focused on sensory evaluation and consumer acceptance testing, quality and management systems by Mr. Piyush Sharma, and as a session on statistical quality control and data interpretation by Ms. Abipriya Patra. Finally, day 5 wrapped with a discussion on food labeling and compliances with FSSA Codex regulation, rapid and non-destructive methods for food quality assessment, and recent advances and future trends in food analysis. It's now my pleasure to invite our course coordinator, Dr. Arun Prasad Venugopal sir, to share his thoughts and reflection on the successful completion of our 5-day workshop. Over to you, sir.
Yeah, am I audible?
Yes, sir, you are audible.
Yeah, thank you, Divyadashni. Yeah, finally we come to the conclusion. For past 5 days, we have been training rigorously regarding this food quality analysis and the techniques involved in food quality analysis. So as Divyadashni said, we have witnessed various lectures and demonstration of equipment usages, and as well as we have discussed about some of the calculation part which most of the workshop they don't show you. I hope the participants have learned a lot from this workshop. From each and every lecture there are so many takeaway messages and there are so many things we have shared with you. Thank you so much participants for making this workshop a grand success. And first of all, I'd like to thank our professor and head, Sabyasachi Mishra, for motivating us to conduct this certificate course on food analysis. And I take this opportunity to thank our director, Professor Uma Maheshwar Rao, and Dean Faculty Welfare, and then the Dean Shrik, who run behind this workshop, who always motivated us to conduct such a workshop in a grand way. And I take this opportunity to thank Professor Vivek Kamampati, who is the mastermind behind this workshop. So one fine day when we were discussing about the analysis technique and the knowledge of undergraduate to those who are graduating from our institute as well as other various institute, where they lack a lot of equipment handling techniques. So they are theoretically they are sound, but when we test their ability to do an analysis in a laboratory level and a laboratory scale, their the ability of them, or the difficulties they face in using the analytical instrumentation, as well as calculating or data interpretation, or like we were discussing about those things, and we want to solve those problems by conducting a workshop, so that it will be helpful for undergraduate. First of all, we designed the course for undergraduate, and later I heard from Dr. Vivek that there are so many industrial people are interested, and there are some master level students is also interested in participating in our workshop. So we motivated all of them to participate, and throughout my lectures, throughout this lecture series, I have seen in the count almost 200 participants are registered. The count didn't reduce below 180 or 190. So during each and every lectures, I can see most of you, even on Sunday, Saturday, irrespective of working day or holiday, I have seen a huge response from the participants. That means this program have reached every one of you with and it I hope it helped a lot in learning about the food analysis and quality control techniques. Finally, not but not the least, this workshop would not be a possible, or it won't be a success, this much bigger success, without the background, without the background strength. So the background strength of this workshop is our scholars, the scholars from our department, food process engineering department, NIT Rourkela. So especially to name them, starts with Abhipriya Patra and Piyush Sharma, my PhD scholars, and then Subhi Singh, Divyadashni, Reshmi, and Rahul. There are so many PhD scholars working every day behind the successful coordination and a successful completion of this workshop. So you would have seen the time management. So when you say that the workshop is going to start by this time, it exactly started by that time. So the time management, there is a team, there is a continuous effort of the team is always behind the successful completion of this team. So this workshop, I appreciate. There is no words to appreciate your involvement and commitment towards delivering a lecture or delivering in giving a back end technical support. Thank you all my students, all our students from the Department of Food Process Engineering, for making this conference a wonderful success. Yeah. Finally, the participants. So I have seen active participation in every lecture. So each and every lecture, there are question and answer session, followed by each and every lecture there is question and answer session. And I have seen questions posted in the WhatsApp groups as well. We have tried our level best to reply back to those WhatsApp queries. There are a lot of questions in chat box. So we have tried our level best to answer all those queries and all those doubts. If something was lagging from our side, if there's something, some question has to be answered, or some technical thing has to be clarified, feel free to contact us through the same WhatsApp group. And I hope you all have our contact details, email IDs, so you can contact us related to any doubts and any research collaboration from your end. So we are open to research collaboration, and if you want to do an internship in NIT Rourkela, or if you want to do an offline course or offline certification course in NIT Rourkela, you are most welcome. So keep watching us through our website and through our Instagram and LinkedIn accounts, so that we will be posting some more workshops, some more research collaboration or JRF position or SRF position in our website. Thank you. Thank you so much for joining. That's all from our side. Thank you, Divyadashni. Take over, please.
Thank you so much, sir, for your valuable time being with us. On behalf of all the participants, I extend our heartfelt gratitude to our esteemed speakers for sharing their expertise and experience throughout these sessions, and our coordinator, Dr. Vivek Kamambati, sir, and our co-coordinator, Dr. Arun Prasad Venugopal, sir, for their meticulous planning, guidance, and constant encouragement throughout the course. So special thanks to all the participants for their active involvement and enthusiasm and feedback that made this program a great success. So regarding the certificates and recordings of the video, certificates will be issued within a week and shared via the registered mail IDs. For any queries or clarification, please don't hesitate to contact us through our WhatsApp channel. we will be continuously posting the updates, and the recordings will be shared soon. So the quiz will be conducted at two different times. Already the one part of quiz has been completed. So participant who didn't attend during the first session can attend the second session. Do not repeat login again. Those who have attended first, and only one response should be considered from each participant. So the link for the second session of the quiz will be shared at the time through the WhatsApp group. Please check the WhatsApp group. And coming to the feedback session, I kindly request any of the participants to share their valuable feedback, which will help us to improve for the future workshop series. So I request any of the participants to come forward and share your experience on this course. Anyone from the participant sites are mostly welcome to share their experience regarding the certificate course. Any feedback to be improved from our side also will be accounted.
Participants, feel free to share your thoughts, and those who are interested to deliver your feedback, please raise your hand or please intimate us so that we can unmute you.
Any queries regarding this also will be welcome during the session. So participants, any queries also will be welcome to the WhatsApp channel, and any feedbacks can also be inquired during this time. So please come forward and share your feedbacks.
Hello.
Yes.
Hello. Am I audible, sir?
Yes, you are audible. Please, share your name and then your feedback. Please tell your name.
Myself,
Yeah.
Vidhan Lade from I am a second student food technology from Anna Sahib Dange College of Engineering, Sangli. Uh, Before joining this session, I was too confused how it will be. Means, will I grab the all knowledge or not? But it was too engaging, and as a second year student, I learned from basic to advanced. Um, I think it will help me a lot in my future. Thanking you all, sirs, and ma'am, you also. Thank you.
Thank you. Anyone else? Please be, free to share your experiences.
Hi, sir. Yeah, good evening, everyone. I am Surendra Reddy. So I'm working with Pharma Service Private Limited. It's a B2B industry for staples.
Okay. Yeah.
So it's very informative session. I completely diverted from my core food tech to operations in this industry. But because of these sessions, certificate course. Uh, Now I'm able to collect all my past experience when I was working with quality and food safety, and my during graduation and post graduation studies. It was very informative session. I covered basics to advanced techniques. One good thing is you people covered QMS and different pareto analysis, uh, fishbone diagram, application, all those. It was very information, and it good for outcomers, and who wants to get some it's like recollecting or learning something in a different way. Even perspective also, industry perspective is different, and when the teaching perspective or during the studies perspective is different. But it's very good in collating between practical versus your what we call lectures. It was very informative, and thank you, sir. Thanks a lot. Giving such a great certificate workshop.
Thank you, sir. Thank you very much. Anyone else?
Thank you, sir. So
Good evening,
for
sir.
sharing thoughts.
Hello.
Good evening. Good evening, sir.
Yeah, good
Yes.
evening. Yeah, myself, Dr. S.M. Lokhande, working as Associate Professor, College of Horticulture and Forestry, Central Agriculture University, Imphal. And this
Good evening,
college
sir.
is
Very good
situated,
evening, sir.
yeah, this college is situated at Pasighat, Arunachal Pradesh.
Yes.
Sir, it was very nice to listen you peoples. It was very great experience because almost you have covered many more things because and it is highly essential for the upcoming students as well for industry peoples and academician researchers. and all the resource person, Vivek sir, then Arun sir, and all the research scholars, they have taken very good efforts, and it was nice to see you peoples, and also you have come forward for the collaborations. Definitely we look forward for the future collaborations with the NIT Rourkela. Thank you for opportunity. Thank you everyone.
Thank you. Thank you. Any other one or two we can take, then we can proceed with Otam.
Hello, sir. I am
Yeah.
Khushi I am audible.
Yes, yes, yes.
Sir, so I am Khushi Saxena. I am a first year PhD research scholar in Panasthali Vidyapeeth, which is situated in Jaipur. So for me, this was a very good experience as I'm a first year student, and mostly we assume the online certification courses are just theory basis, only theory. But in this session, I personally liked the second half, in which we also get a practical knowledge of every kind of tools, and um, proper video was given to us for every kind of tests. So that was a really good part of the lectures, and personally I liked it, and it helped me a lot. As a first year student, it is very helpful for me.
Thank you. Thank you, Kushi.
Good evening, everyone. I'm Nasiha from JNTU College of Engineering, Kalki. I just graduated my BTech. I want to express my sincere appreciation for this online workshop, especially the practical demonstration of proximate analysis and demonstrations of various equipments, which helpful in understanding the applications of theoretical concepts. The session was very well structured and instructors are very knowledgeable. Thank you for this opportunity, and thank you all.
Thank you. Thank you very much. I think Divya, we are good to go, right?
Yes, sir.
Yeah.
So thank you each and everyone who are there to share your thoughts, and it will be more encouraging for us for the future workshops. So and now I would like to invite our coordinator, Dr. Vivek Kamambati sir, to deliver the closing remarks. Sir, please.
Thank you, Divya. First of all, good evening, everyone. Definitely, it is my great privilege and pleasure, as well as honor, to deliver the vote of thanks for this wonderful workshop, wonderful certificate course on behalf of organizing team. Right. So for the past 5 days, you have learned around 20 different lectures. Okay. You have learned many things. First and foremost, I would like to express my heartfelt gratitude to our PhD scholars. Right. Abhipriya Patra, Piyush Sharma, Rashmi, Subhi Singh, and Divya Darshini. Okay, they are our PhD scholars. You would have seen their dedication towards delivering the content, right? And I would like to thank them for meticulously handling all the demonstration sessions and for their clarity in explaining complex concepts. Their dedication, hard work, and commitment were truly the backbone of this particular course. I'm sure all of you have witnessed their sincerity during this particular different sessions in this course. Without their efforts, this program would not have been possible. Thank you all once again for your outstanding contribution. I would also like to extend my sincere thanks to our institute head as well as institute for providing us with the freedom and access to all the laboratory facilities and equipment available 24/7 without any restrictions, which enabled us to conduct the demonstration smoothly. A special word of gratitude to our beloved director, sir, Professor Uma Maheshwar Rao, for his constant encouragement and support, and to our head of the department, Professor Sabyasachi Mishra, sir, for his constant guidance, motivation to young faculty like us. My heartfelt thanks also goes to our co-coordinator, Dr. Arun Prasad Venugopal, for his constant support and involvement right from the planning stage to the successful completion of this course. Thank you, sir, for always being there for us. Thank to all the participants. Thank you so much for your enthusiastic participation, your interactions, and your valuable feedback throughout the sessions. We truly hope that this course met your expectations and encouraged your understanding of food analysis and quality control. We could see this from the number of feedback just happened now. If there were any small lapses, please pardon us. We assure you that we will take this as a lesson and come back even stronger and better next time. Before concluding, I would like to inform you that the certificate will be issued within a week after completion of the payment verification process. As you know, attending the quiz is mandatory for certification. So those who missed the first quiz are kindly requested to take the second quiz at 6:30 p.m. The link will be shared in the WhatsApp group shortly. So please make sure you don't miss it. Once again, thank you very much for being part of this journey and for making this certificate course a great success. And also I would like to, share your experiences in the social media platform, LinkedIn and Facebook, and tag NIT Rourkela and us. Okay, thank you very much. Thank you, everyone. Thank you, all the participants.
Thank you, sir. Thank you so much for your valuable time to being with us. So as we conclude this certificate course, I want to tell you about the instruction, special instruction for the second session of the quiz. Please listen. Attempt all the questions. Each questions carry 2 marks. There is no negative marking. The test consisting of 30 questions. Total duration of the test is 15 minutes. After the allotted time, the test will be submitted automatically. Do not switch tabs or minimize the test window. Doing so will result in automatic logout and termination of the test. Only one attempt is allowed per participant. Ensure a stable internet connection throughout the test. Use a laptop or a desktop for better visibility and smooth performances. Keep your device fully charged or connected to a power source. Do not refresh or close the browser during the test. Read each question carefully before answering and review your responses before the time ends. In case of any technical issues, immediately inform the course coordinator. And also, if you are late for during the quiz, there is no extra time will be given. So it is an automated process. So please join sharply by 6:30 p.m. And as we conclude this workshop, let's carry forward the knowledge and inspiration we have gained here into our research and professional endeavors. Thank you all once again for being part of this academic journey. Thank you all.